Good morning. So today we're looking at experimental design. So experimental design basically means who does what. So when it comes to, excuse me, when it comes to assigning the participants to different conditions in our experiment, how do we do that? What ways can we do that? Sorry, it's a little bit blurry. Okay, so experimental design, who does what? How do we organise our participants? How are participants organised? Okay, so what we have here is with a circle, and in that we are going to put all our participants that are taking part. Okay, so lots and lots of participants. Right, so the first type of experimental design that we could use is called repeated measures. Okay, so repeated measures, what happens there is that all of our participants will do the first condition of our experiment, and then because it's repeated measures, all participants will then do the second condition of our experiment. So let's say we were investigating the effect of, I'll just always use that, of coffee on concentration. Condition 1, participants will have 5 milligrams of coffee. Condition 2, they will have 0 milligrams of coffee. And they will be given a task to do in each condition, and then we will measure their concentration. So that's just what we mean, condition 1, condition 2, just the different, if you think of your IV, the different conditions, so the different, what's changed from one condition to the other, what are we actually investigating? So that's just what we mean by the condition 1 and the condition 2. So a repeated measures design, all participants will do condition 1 and the results will be recorded. And then they will all move to condition 2 and the results will be recorded. So you will see, I've sent you a PowerPoint and it's like a wee animation type of thing, and that if you're able to get onto it, it's quite good. But you also need to know, well, why would we want to use a repeated measure? What are the advantages of a repeated measures design, and then what are the disadvantages? So you can see there, if all participants are doing condition 1, all participants are doing condition 2, then we only need one set of participants. So that's an advantage. Less participants are needed, because if I wanted to have a sample size, that's our participant number, if I wanted to have a sample size of 20, then I only need 20, because the whole 20 are going to do condition 1 and the same 20 are going to do condition 2. But something that you will also read is with repeated measures, what can happen is, because we're using the same participants for both conditions, by the time they get to condition 2, lots of things might have happened. They might have worked out what the aim of this study is. So by the time they get to condition 2, they may not be acting or behaving in a natural way, and therefore our results might not be valid. Also, if it was a task that involved lots of concentration or lots of energy being used, again, by the time they get to condition 2, they're going to be tired. They might be bored. So that means they're going to do worse in this condition. Or in actual fact, they might do even better in this condition because they've kind of practiced. They've been able to use condition 1 as like a wee practice run or a trial run and do even better in condition 2. Regardless of what those effects are, whether it's the tiredness or whether it's practice or whether it's working out the true aim, the issue is the results that we get in the second condition aren't going to be reliable. And they're not going to be valid. We're not going to be measuring the effect of concentration. What we're measuring is how well were they able to learn from condition 1 to help them in condition 2. And that's not what our IV is all about. Our IV should only be the effect of coffee or caffeine. Okay, so one way of getting over this issue of the order effects or practice effects is this word called counterbalancing, which means that instead of everybody doing condition 1 followed by condition 2, what we do is we take our sample. Okay, so this is our sample again, and we'll split them in half. Condition 1, condition 2. Half of our participants will do condition 1 followed by condition 2, and the other half will start with condition 2 and then move on to condition 1. Now, you're still getting order effects because the participants who start here may be tired by the time they get here. But the good thing with counterbalancing is that the other half of the participants will have started on this condition, and then they may have got tired by the time they got to condition 1. So it kind of just balances out the order effects a wee bit more, so that it's not always condition 2 that's being affected negatively, because half the participants will be doing this first condition as, like, you know, the second, basically. Condition 1 will be done secondly. So it's not all condition 2 being affected. So results should just be a wee bit more balanced. Okay, so that is our first experimental design, repeated measures. Everybody does condition 1 and then everybody does condition 2. Issue is order effects that always are negative for condition 2. However, it can be overcome. Right, moving on. Our second type of experimental design. Again, here are all our little, oh, getting worse. All our little participants. Okay, this next experimental design is called independent groups. Okay, and our keyword is independent. So what we do with independent groups design is that half of our participants do condition 1 and the other half do condition 2. Okay, so 2 different sets of participants. One set will do condition 1 and one set will do condition 2. Now, the negative of that is that if we need a sample size of 20, then that means 20 for condition 1 and then 20 for condition 2. And because these are different people in each condition, that means actually we need twice the number of participants. We would need 40. So you will find with the independent groups compared to repeated measures, the advantages of one become the disadvantages for the other. So we said that the good thing with repeated measures is that we only needed one set of participants because everybody did both conditions. So therefore, a disadvantage of independent groups is that we need twice the number of participants because each group only does one condition. Now, a negative of the first one, repeated measures, a negative of that was the order effects, the fact that condition 2 was always being affected negatively. Whereas if one group of participants is doing condition 1 and a different group of participants is doing condition 2, and that's it, then there's no order effects. So we don't need counterbalance and we don't need anything like that. But one of the main issues with independent groups is individual differences. What happens if naturally, without any kind of input from the researcher, what happens if there's more people in condition 2 in condition 1 that are tolerant to the effects of caffeine? What if we've loads of coffee drinkers that just happen to be in condition 1? Then the effects of taking 15 milligrams of coffee might not have a significant effect in their concentration. So because the 2 groups of participants are completely different, we might find that we have some participants in a condition that are very, very different from the type of participants in another condition. and therefore we're not measuring the effects of caffeine, we're measuring tolerance of caffeine, or we're measuring history of caffeine. So you can see how we start to move away from what our IV actually is if there are individual differences. But a way of overcoming that is something called randomization. And that means that when we are assigning participants to condition 1 and condition 2, we do it in a completely randomized way. So we will put all the names into a hat. So say all our 40 names go into a hat, and then we draw out 20. And those first 20 names drawn out will be assigned to condition 1. And the remaining 20 names will then be assigned to condition 2. Now, you're still not guaranteed to have an equal balance of different types of people in each condition, but randomization just works in the law of probability. So it's more likely that we will have, just based on the laws of probability, that we will have a more mixed group in each condition. So it's just one way to try and overcome those individual differences. Okay, and our third and final experimental design. Here's our participants. Okay, and this experimental design is called matched pairs. So this is a very good way to try to make sure we don't have individual differences. So in a matched pairs design, you first of all recruit your 20 participants, and they will be assigned to condition 1. Okay, so your 20 participants are all in group 1. They're all people, by the way, not ours. And then what you do is you find out a bit about your first 20 participants, and you want to find out something that you think is necessary in relation to your experiment. So in the coffee one, we would want to find out, right, what type of coffee drinkers are these? And let's say we find one participant is someone who never drinks coffee. Then what we will want to do is we will want to recruit a participant for condition 2 that matches them and is somebody who never drinks coffee. If we find that somebody else in our original sample is a big coffee drinker and drinks 10 cups of coffee a day, we will want to recruit a participant for our second condition who is someone who drinks 10 cups of coffee a day. So that's what we mean by matched pairs. Everybody in condition 1 is matched with somebody from condition 2. Now they're matched for a characteristic that is relevant to our experiment. Okay, so for example, we could match them up by hair color, but hair color is not going to be anything that affects affects our experiment on coffee and concentration. So it has to be a match in terms of a characteristic that might have an effect on our experiment and the results that we get. Okay, so that's a matched pair. Issues with the matched pair, again, you're recruiting twice the number of participants because you have your initial 20, and then you have to match them by a different 20. It's also very, very time consuming because you're going to have to try and match them and find their match in your recruits for people who are similar in different characteristics. Another issue is if one person decides to withdraw from the study, you have to lose their pair as well. So you're losing double the number of participants for anyone who withdraws from your experiment. Okay, so that's as much as I can teach you. You'll see in the email, there's a PowerPoint if you can get it open. There is also worksheets to work through. Use the textbook, use this. And then there's a wee exercise for you to do at the end, which is just like a wee matching exercise where you just colour in the boxes that link to each of the experimental designs. All right, so I'll chat to you tomorrow again. Bye.